All right, number 6, in a library on a university campus, there's a sign in the elevator that indicates a limit of 16 persons. Furthermore, there is a weight limit of 2,500 pounds. Assume the average weight of students, faculty, and staff on campus is 150, and that the standard deviation is 27 pounds, and that the distribution of weights of individuals on campus is approximately normal. If a random sample of 16 persons from campus is taken, what is the expected value of the mean sample of their weights? Well, this is a sample distribution of a normal distribution. So if I expect on average each person to be 150, then I'd expect 16 people to be 150. So part A is 150. Let me kind of pause real quick. Okay, let me kind of continue from this screen since I already wrote it out. The standard deviation for the sampling distribution, since we're talking about 16 people, then I would want to take the population standard deviation of 27 and divide that by the square root of n, which gives me 6.75. What is the average weight for a sample of 16 people that result in exceeding 2,500? So let's take that 2,500, divide by 16, and see what number we get, and that's 156.25. Okay, and so now the question is, what's the probability that a randomly selected group of 16 will exceed that weight limit? So we're talking about a norm CDF here. So if I expect 150, standard deviation is 6.75, what percent of the time am I going to exceed that? So that would be a norm CDF scenario. Let me kind of pull that up. Okay, so here we are. I want to do a norm CDF, but keep in mind norm CDF measures things in terms of less than. So even though I am want to know bigger than 156.25, I need to kind of switch the question on me here. So what I'm going to do is or what we do in this case, is I'm going to take this 1 minus the norm CDF of from 156 to 150, because again, norm CDF will measure it in terms of less than. If I want greater than, then I just want to subtract that number from 1. So norm distribution, 156.25 with a mean of 150, standard deviation is 6.75, and then I'll just select true. And so I would unfortunately expect 16 people to exceed that weight limit about 17-18% of the time. So that's a little upsetting for me. 18% of the time so 1 out of 5 times I get on the elevator, it could be the last time I get on an elevator. But anyway, so that's what the numbers work out to be. All right, number 10, information on a packet of seeds claims that the germination rate is 92%. What's the probability that more than 95% of 160 seeds in the packet will germinate? Okay, so first thing that we should catch is we're talking about some sort of sampling process, because they do give me a sample size of 160, but we've got 2 different sampling processes. We've got sample means and sample proportion. And this time, my data is in terms of percent. So I expect 92%. I want to know what percent, how often do I get more than 95%? But I'm expecting 92%, that being a percent. So I want to calculate sample proportion, the sample mean and sample standard deviation for this proportion. So sample means, in this case, is still 0.92, because that's what I expect to happen. Okay, sample standard deviation for proportions, I want to take the square root of 0.92 times 1 minus 0.92, and then I want to divide that by the sample size. So divide that by 160, and I get that lovely decimal. Okay. All right, so I want to know how often I would expect to see this more than 95%. So that's a norm CDF question. Norm CDF measures things in terms of less than. I'm being asked more than, so I do that 1 minus trick. So 1 minus the norm distribution of my observation is 0.95. I expect 0.92. Standard deviation is that decimal we typed. and then true. So I would expect to see more than 95% of the packet germinate about 8% of the time. All right, number 11, certain chromosome defect occurs in 1 out of 30 adult Caucasian males. Random sample of 50 adult males is obtained. What is the mean value of the sample proportion and the standard deviation of this? Well, up in the setup, they tell me that I expected to see 1 out of 30, so that's actually my proportion. I expect 1 out of 30 or 1/30th. So let me get that typed up. And then the standard deviation is the same proportion formula. So it's the square root of p hat, so 1/30th, times 1 minus p hat. In this case, it's 29 out of 30, divided by the standard deviation. So that gives us, works out to be about 0.025. Part B wants to know if this is approximately normal, and if not, why. Well, with proportions, what I want to do is I'm going to take the sample size and multiply by p and then 1 minus p. So if I take 50 times 1 over 30, I get 1.67. In order for it to be normal, it's supposed to be bigger than 10, and it's not in this case. So what that tells me is my sample just isn't large enough to do a normal process. Now, quick question, why do we even care about normal distribution? And the answer is we love norm CDF and we love norm inverse. Those two functions allow us to make a lot of observations about our data. So I want it to be normal. Now, if it's not normal, we can still do some analysis. That's another statistics course beyond this one. So this class, we're all about finding out if it's normal, and if it is, then analyze using normal means. But that's pretty much why we care if it's normal. Number 12, the Gallup organization conducted a national study on crime victimizations and reports that 25% of all households experience some sort of crime. In a random sample of 300 Plano households, 68 report that they experience some sort of crime. Construct a 95% confidence interval for the true proportion of Plano households that have experienced some sort of crime. Then based on this interval, is there evidence to suggest that Plano is different or less than the national average? Okay, so in one of the cool toys we have is this lovely little spreadsheet here. And I can actually use it to answer this question. Now, this is, we'll actually come back to this when we do inference models. But this will actually do confidence levels for us. You're more than welcome to use the calculator and figure out the settings for it. But in this case, I just need to type in what we call successes. So 68 out of n, so 300. Confidence level is 95. Now these other two things mean nothing to us right now. We'll come back and play with this when we get to the 4th unit on inference. But what does make a difference is right down here at the bottom. 0.179 and 0.024, which is the confidence level we're interested in. Let me kind of take a picture of this. Right there is the answer to our question. Okay. And then the other part, and the other question that we asked to look at is, based on this interval, is there evidence that it's less than the national proportion? Well, what does the nation expect? The nation expects about 25%. And based on the 68 and the 300, we would predict that this area is somewhere between 18% and 27%. So is that any different than the nation? Well, no, because 25% is somewhere in that interval. So it's possible it could be 25% exactly. We would have to, the interval would have to not contain that number at all in order for it to be significant. So let's say the national average was 29%. Well, 29% is outside of my interval, so this definitely would be evidence that Plano is different and even less than the national proportion. But again, we were asked to compare it against 25, so that's what we're going to go with on that. All right, number 13, crop researchers plant 34 plots with a new variety of corn. Their average yield in bushels per acre is 123.33. Standard deviation is 15. What is the shape of the sampling distribution? And and explain how we know that. Okay, again, whenever we're asked to talk about sampling distribution shapes, we're trying to see if there's evidence that it's normal. And there's kind of a couple of ways we can do that. One, the population itself can be normal. Now, they didn't say that in this case, so I can't say that. I can't state that's my justification. I could have a large enough sample size. So for this, because we're talking about means instead of proportions, then I can look at the n, how many what the size of the sample is, and as long as it's bigger than 30, then the normal model is appropriate. We've got 34, so clearly we're good there. The third way we can look at it is some sort of graphical justification, either a box plot or a histogram, or a normal probability plot would be also sufficient. Now the graphical justification we don't need because we have 34, so we're totally fine here. So what I can do then is I can go to our nice fancy spreadsheet, and this time the only other spreadsheet that we need to worry about is this one sample t-test one, and I can just let's see, get my numbers right, 90%. Okay, and so I'll just type in my mean of 123.33, standard deviation of 15, and sample size of 34. And then I just need to make sure my confidence level matches, so it is a 90%, just so happens that's what I've got typed in. And so right here, these numbers down here, take the picture, those guys, that's our confidence level, okay? Again, we'll revisit this spreadsheet when we look at inference procedures in Unit 4. So a lot of this other stuff, we don't really know what it does, but we can read off the confidence level just fine here. So our estimate for the population would be somewhere between 118.9 and 127.7. All right, number 14, we're given a set of data, and we're asked kind of the same two questions. What kind of sampling distribution is it? And then give a 95% confidence level. Okay, so as far as sampling distributions, now in this case, we don't have a large enough sample by itself to say it's normal. We weren't told the population was normal, and so the third method is to go to some sort of graphical display. And so if you type that in either a calculator or an Excel spreadsheet, you can generate either a histogram or box plot. I believe I went with box plot on the answer key. Okay, so yeah, that's exactly what I did, is I just typed in the numbers and just found out the 5-number summary and sketched a quick box plot just to get evidence that it is approximately normal. As far as the confidence interval goes, kind of back up here. So this is where in our nice fancy spreadsheet, I'm going to get rid of these numbers, and then I can come over here and I can just type that in. So 24.12, 24.01, another 24.01. Okay, I'm going to keep typing. You don't necessarily need to watch me type this whole thing out. Okay, so once I've got the numbers typed in, then I come down here to the confidence level, and it's somewhere between those two values. So right down here. Actually, I'm wrong, because it is a 95. So I need to change this to say 0.95. Okay, and then I'm going to take a picture of the answer. So somewhere between 23.9 and 24.03 would be the answer to that confidence level.